All right, 5-2, adding and subtracting polynomials. Okay, so before we get to do any work, let's do some notation out of the way, or some words out of the way. Term. A term is the product, or excuse me, sorry about that. It is a number, variable, or product. It is multiplication of numbers and variables raised to a power. All right, we'll make note of those in a little bit when we get to them. All right, coefficient is the number in front of a term. All right, it's the number part of a term. So if there's, say, 5x squared, that's an example of a term. 5 would be the coefficient. Okay, the whole thing would be considered a term. All right, and a constant is if you have a term that is just a number. It has no variables in it. It's just constant. A term that is just a number. All right, a polynomial is a string or sum or difference. Difference is the kind of equivalent to sum here. It's just the opposite, or adding a negative. But it's a finite sum of a whole bunch of these parts. Okay, it could be 1, it could be 25. Okay, but it's a string of terms put together with pluses or minuses in the middle. All right, and some ways we describe polynomials is we can describe them by the number of terms they have. And so monomial would be 1 term, binomial for 2, notice the prefix bi like bicycle, and trinomial with 3. Anything else we have is, we have more terms than that. We have 5 terms. Okay, there's probably some words out there, but we don't use them in general. So monomial for 1 term, binomial for 2, trinomial for 3. All right, another way we talk about a term is we talk about its degree. All right, the degree of a single term is the sum of all the exponents of the variables contained in the term. Okay, so on example 1 here, we have just the one variable with the exponent. So this would have a degree of 2 because the exponent is 2. All right, for b, we have multiple variables in this one term. We have a 3 for the first, for the x, a 1 for the y, and a 1 for the z. Those are understood there. So if we add all those exponents up together, we get a degree of 5. Okay, so you add up all of the exponents of the variables. And then for c, if there are no variables, that has a degree of 0. If it's just a constant, it's a degree of 0. All right, so try the practice ones and then I'll write the answers out. All right, for your degrees for A, we just have the 3, so your degree is 3. For B, we have 2 plus 5 plus 1, so that's a degree of 8. And for C, we have a degree of 0. All right, now the degree of a polynomial, okay, is you do each individual term, and then whatever term gives you the greatest degree, that is the degree of the polynomial. Okay, so you do each individual term, and then whichever one's the highest. So kind of going through here, this one says find the degree, and then tell whether it's a monomial, binomial, trinomial, or none of these. So for A, as far as degree is concerned, the first one has a degree of 2, the first term. Second term has a degree of 1. And the third term has a degree of 0. So the highest degree is the 2. So overall, the polynomial has a degree of 2. So this is second degree. All right, and then as far as the number of terms it has 1, 2, 3 terms. So this is a second degree trinomial. All right, and the reason why we do this, it tells us a lot about what that expression or what that function is going to look like on a graph or the way it behaves just in general. All right, B, we have the x, which has a degree of 1. We have the constant term 10, which has a degree of 0. So the highest degree is 1, so this is a first degree. And then we have 2 terms, so it's a binomial. All right, and then for C, if we look at our degrees, we have a degree of 1, a degree of 3, a degree of 2, and a degree of 0. So this has a third degree. It's a degree of 3. All right, and since it has 4 terms, this is going to be none of those. Okay, it's not a monomial, binomial, or trinomial because it has 4 terms. All right, so try these out, and I'll write the answers on the canvas to save time for the video. All right, so just a little bit more working with these. We have more complex polynomial going on here. All right, but if we talk about the degree of each part, okay, and then we can give the degree of the entire polynomial. So let's look at the first term, 7x squared y. The numerical coefficient, it's the number in front, that's a 7. And then the degree of the term is if we add the exponents, 2 plus 1, we have a degree of 3. Second term, minus 6xy. Numerical coefficient is negative 6. Exponents of 1 and 1 for the x and y to give me 1 plus 1, we have a degree of 2. Next term, there's not a number written in front, so it's understood to be 1. There's only one variable, and its exponent is 2, so it's a degree of 2. The fourth term is a negative 3y, so its numerical coefficient is negative 3. The exponent for the y is 1, so degree of 1. All right, and then the numerical coefficient, that's all we have, is the 7, so 7, and it has a degree of 0. So as far as the polynomial is concerned, the highest degree tells me the degree of the polynomial, and so that degree is going to be 3. The third degree polynomial here. All right, now write the answers to the practice on the PDF that I'll put online on Canvas. All right, now evaluating polynomials. Find the value of each polynomial when x is negative 2. All this means is everywhere you see an x, substitute it a negative 2. So for A, we'll have negative 5, and then we'll substitute a negative 2 in for the x, and then plus 6. So negative 5x plus 6, negative 5 times what the x is equal to, plus the 6. And then use order of operations. Multiplication, negative 5 times negative 2 is a positive 10. And then plus the 6, and then 10 plus 6 is 16. All right, for B, we have 3. We have negative 2 for the x squared minus 2, and then the x will become a negative 2 plus 1. So notice I put the negative 2 in for x. Order of operations, I'll do exponents first. So negative 2 squared, that's negative 2 times negative 2, so that turns into 4. I'll just write everything else out. Then I'll go through do multiplication. 3 times 4 is 12. A minus 2 times negative 2 gives me plus 4. And then plus 1. Then addition, 12 plus 4 is 16, plus 1 is 17. All right, so when you find the value of a polynomial, you substitute the number in for the variable and do order of operations. Okay, again, try your practice out. Answers are going to be 31, 10 plus 15, 33, I think 36 here. All right, now this looks like a word problem, and it is. Okay, but really all it is just they give you all this information, but we're just plugging stuff in. So we have a building, it's 592.1 feet tall, object is dropped, neglecting air resistance, we have this expression right here. Okay, the time in seconds, and the expression tells me the height in feet the object is from the ground. And it says find the height at 1 second and at 6 seconds. All right, so all we have to do here is plug those numbers into our formula. All right, so our expression will have a negative 16. When t is 1, we have 1 squared plus 592.1. 1 squared is 1, so negative 16 times 1 plus the 592.1. So it gives me negative 16 plus 592.1. And then we put that together, that gives me a 576, I believe, 0.1. All right, then it tells us to do it when t is equal to 6. All right, so when t is equal to 6, I have negative 16 times 6 squared plus 592.1. All right, so it's again exactly like the previous example, except it's got in a word problem. All right, negative 16. 6 squared, exponent first, is 36, plus the 592.1. All right, and then we multiply that out, negative 16 times 36. Do that out, and we grab my calculator out. All right, that gives me 576. That's a negative 576 plus the 592.1. All right, and so that's going to end up giving me 16. All right, so it looks like it's a hard word problem, but they give you the polynomial and they give you the numbers to plug it in. So it's exactly like the previous problem, example 4. It just has all these words that tell you a situation. Okay, I'll do the practice and put it on Canvas. All right, simplifying. Okay, we can simplify a polynomial by combining like terms. Okay, and like terms are terms that have the exact same variable and the exact same exponent. Okay, so for A, x and x, they both have x's in them. All right, and both those x's are raised to the first power. So when we combine them, we have negative 3x plus 7x. All we have to do is combine the coefficients. So really all we're doing here is saying negative 3 plus 7, which gives me 4. And so I've got 4 x's. Okay, when it says simplify by combining any like terms, if they have the same variable, you just combine the coefficients. All right, B, we have x plus 3x squared. Now on this one, they have the same variable, but the second term has something raised to the variable raised to the second power. The first term only has it raised to the first power, so I cannot combine those two. Those are not the same. So that one just stays as it is. All right, for C, I've got 9x to the third plus x to the third. All right, they do have the same variable with the same exponent, so I combine the coefficients. The second term has a coefficient understood of 1, so 9 plus 1 gives me 10 x to the third. All right, for D, 11x squared plus 5 plus 2x squared minus 7. All right, I can combine some of this stuff. I've got the 11x squared and the 2x squared. They're both x squared terms, so those can go together. 11 plus 2 gives me 13 of those x squared terms. And I can combine the constants. 5 minus 7, which gives me minus 2. Okay, and I like to underline in different ways just to know I've used all the terms. Okay, but anything that's alike as far as variable and exponent can be combined. All right, E. They got to throw fractions in there on us. 2/5 x to the 4th plus 2/3 x to the 3rd minus x squared plus 1/10 x to the 4th minus 1/6 x to the 3rd. All right, so let's see what we can combine. I've got 2/5 and I've got a 1/10, both raised to the x to the 4th. All right, so I need to combine those two. So I know I'm going to have an x to the 4th term. All right, but over to the side, I'm going to say, hey, they need to have a common denominator. So 2/5, when I multiply that by 2 on top and bottom, all right, that becomes 4 over 10. And if I add that to the 1 over 10, that gives me 5 over 10, which reduces to 1/2. Okay, so we got to do the fraction things that we've talked about previously. It's just now in this polynomial combining problem. All right, our third terms, we have 2/3 x to the 3rd minus 1/6 x to the 3rd. All right, so again, I need a common denominator. I multiply by 2 on top and bottom here. Right over to the left here, it gives me 4 over 6. And then minus the 1 over 6 from the other x to the 3rd term. That gives me 3 over 6, which again reduces to 1/2. So we also have a 1/2 x to the 3rd. And then we have not used this x squared. That's the only term there is with x squared. So I just write it down. All right. So combine them. You might have to do fractions and find a common denominator, but just with the ones that have the same variable with the same exponent. You know, put the practice answers on Canvas. All right, a little bit more work with that. Let's look through here. I like to go term by term. Negative 9x squared. There are no other x squared terms, so I'll just write it down. All right, we have a 3xy. All right, we also have a 7yx. And even though those are not in the same order, they have the same variable raised to the same exponent. They're both x to the 1st and y to the 1st, so I can put those together. So 3 plus 7 gives me 10 xy. And I like to put it in alphabetical order. And then finally we have a y squared, so minus 5y squared. All right, so notice I do not put the x squared and the y squared together because it's two different variables. But I can put the xy and the yx together because they're exactly the same. They just have different signs. All right, try the practice out. All right, here's your answer. 5xy minus 3x squared plus 5y squared. All right, adding polynomials is exactly the same thing. We just have it written out differently. Okay, we have, tells us to add these two. We've got negative 2x squared plus 5x minus 1 plus negative 2x squared plus x plus 3. All right, if it's just adding, we don't need the parentheses. We're just going to rewrite it without the parentheses. So negative 2x squared plus 5x minus 1. Since we have plus and negative, we're going to have, that looks like a weird symbol there. All right, plus and negative, I'm just going to write out as minus 2x squared plus x plus 3. Okay, the adding and the plus and negative is just minus. All right, and then now we can combine. Got negative 2x squared and negative 2x squared. So negative 2 minus 2 gives me a negative 4 of those x squareds. 5x and x, that's understood 1x. So together that gives me plus 6x. And then constants, I got negative 1 plus 3. So negative 1 plus 3 gives me a positive 2. Okay, so just combine like terms basically again. All right, practice it out. Pause it. All right, here you go. I'll have negative 3x squared minus 4x plus 9 plus 2x squared minus 2x. I can drop the parentheses. Negative 3x squared minus 4x plus 9 plus the 2x squared minus the 2x. All right, then I can combine. Negative 3x squared plus 2x squared. Negative 3 plus the 2 gives me a negative 1, or just a negative x squared. Negative 4x minus 2x gives me a minus 6x. And then the plus the 9, because the 9 is all by itself. All right, just a little bit more of that. Okay, again, when I'm adding, I don't need the parentheses. Those are just grouping. So 4x to the third minus 6x squared plus 2x plus 7 plus 5x squared minus 2x. All right, and then I go through and I combine. 4x to the third is the only x third term I have, so I just write it down. I've got negative 6x squared plus 5x squared. So negative 6 plus 5 gives me a negative 1, or negative x squared. I've got 2x minus 2x. So those actually, 2 minus 2 goes away. Those cancel together to 0. And then I've got the plus 7. Okay? That's how those work. I'll put the example or the practice on Canvas. All right, and then we have subtracting polynomials. The only difference here is we've got to change the signs of the terms in the polynomial being subtracted. Okay, so it's like you're using the distributive property. It's like there's a negative 1 in front of the second parentheses. So when I rewrite it, I've got 5x to the minus 3 for the first term, but I need to distribute the negative 1 through. So it gives me a minus 2x, and then negative 1 times a negative 11 gives me a plus 11. Okay, that is the only difference in this and the addition ones, is we got to distribute that negative throughout the second parentheses. And then now we combine like terms. 5x minus 2x gives me 3x. And negative 3 plus 11 gives me plus 8. All right, you can pause it and practice it. All right, here it is. You got 8x minus 7, so the first one just comes down. And I need to distribute that negative 1 through. So it becomes a minus 3x, and then a plus 6. Negative 1 times negative 6 is positive 6. Combine like terms. 8x minus 3x, that gives me 5x. And negative 7 plus 6 gives me minus 1. All right, a little more detailed because we have more terms. It's exactly the same. Rewrite the first one, 2x to the third. plus 8x squared minus 6x. Distribute the negative 1. That gives me minus 2x to the third. Negative 1 times the negative x squared gives me positive x squared. And negative 1 times the positive 1 gives me minus 1. Then I combine like terms. I've got 2x to the third minus 2x to the third. Those cancel out because 2 minus 2 is 0. I've got 8x squared plus 1x squared. So we've got 9x squared. I've got a minus 6x. That's the only term with x in it, so minus 6x. And then I've got the minus 1, the only constant, so I rewrite it. All right, try your practice. All right, here's your answer. We're going to have 2x to the third minus 4x squared plus 4x minus 6. All right, and then we have a little word problem here. This is subtract this 5z minus 7 from the sum of these two. All right, and so we talked about it before. Subtract from means I do want to do minus. I want to do the 5z minus 7 as the last part. When you see subtract from, you're going to switch the order. So I'm going to subtract that from the sum of these two. So I'm going to say 8z plus 11 plus 9z minus 2. I'm going to sum those two together and then subtract the 5z minus 7. All right. And then let's go ahead and just rewrite it without parentheses. 8z plus 11 plus 9z minus 2. I do need to distribute this negative 1 through. So minus 5z plus 7. And then combine. I've got 8, 9, and negative 5 for my z's. So 8 plus 9 is 17. 17 minus 5 gives me 12. So I have 12 z's. And then 11 minus 2 is 9, and 9 plus 7 is 16. So 12z plus 16 is my answer. All right, I'll write up the other one for your Canvas. All right, and so finally, this last problem here, and it's just got a whole bunch of junk on it, but it's pretty much the same. All right, for A. All right, it's a plus in the middle, so I can just rewrite it. 3x squared minus 6xy plus 5y squared. Since it's a plus and negative, I get a minus 2x squared plus the 8xy minus the y squared. I combine like terms. 3x squared minus 2x squared. 3 minus 2 is 1. So 1x squared. I've got minus 6xy plus 8xy. Minus 6 plus 8 gives me 2xy. And then 5y squared minus, that's a understood 1. So 5 minus 1 gives me 4y squared. All right, and then for B, I can rewrite the first one. 9a squared b squared plus 6ab minus 3ab squared. I do want to distribute the negative 1 through. So minus 5. I'll go ahead and rewrite it in alphabetical order. So a and then b squared. Minus 1 times the 2ab gives me minus 2ab. A negative 1 times a negative 3 will give me plus 3. And a negative 1 times a minus 9b squared gives me plus 9b squared. Alright, so let's put it all together. 9a squared b squared. I checked through there and there's no other terms that have a squared and b squared, so I just write it down. Alright, 6ab. Well, I've got a minus 2ab here, so 6 minus 2 gives me 4ab. Then I've got a minus 3ab squared. I've also got a 5ab squared, so I can put those together. Negative 3 minus 5 gives me negative 8ab squared. And then I've got a plus 3. That's the only constant. And then I've got a 9b squared, which has the only b squared term by itself, so plus 9b squared. And there's your answer. Okay, a lot of little stuff in there. It's got to be really careful. Put the practice on Canvas. Try these out. Try your MyLab mastering and email me if you got questions.